Hello, welcome to another video. I haven't done one in a long time, always introduce it like that. Today we're going to be looking at something related to Citadel. Citadel was a financial piece of malware from the 2010s, and so I'm thinking it's probably been very much analyzed. It's openly available on GitHub. I'm not going to be discussing maybe the web injects aspect of it, but what I'm going to be talking about is just a little bit of fun, really. Reverse engineering the hardware ID element of the Citadel software, malware. And this basically generates the hardware ID that would be used in a builder to track the samples that they had. So if I open this up, you'll see it takes a bit of time to calculate. It feels like it's doing really complex stuff there, but it's really not. And you get a hash. Super cool. So what we're going to do is, I believe this is UPX packed. Yes, so I've got it in here. And what I'm going to do, I'm going to be using IDA free. So that's super good. We've got one here. I'm just going to overwrite it so there's nothing in there that's too problematic. We're just going to have a little look at that and have a little bit of fun. And I'm just going to talk about the reverse engineering process that I'm using and going from there. So from the get-go, we can see init common controls. I don't think that's too confusing, because when we launch this, we get a load of controls. We've got a text area. We've got some labels there. You can see that. I think even if we went into process hacker and then went into miscellaneous, we might be able to see the GDI handles, right? Yeah, so we can see a bunch of different, like the fonts basically. We can't really manipulate much. There isn't any buttons or different types of windows, but there's a number of, to be fair, that didn't really explain or show too much, so we might as well get on with the show and just have a look at what we can find. Now, most people, when they start up reverse engineering on the IDA 64, will slap into strings, which is completely valid to do. No one should be shaming anyone by not going into strings. We can see a lot of interesting stuff here. If you don't see strings that you see in hex editors, it might be that you don't see the Unicode C style has been checked. So what you can do is you right click, set up, go into the Unicode C style, put the different types that you're doing. So if you're on a Delphi binary, you're probably going to want to do that. And for the others as well, maybe change the strings. Anyway, if we look at calculating, which is probably what we're going to be looking for, because when we open this up, we see the label is calculating. We can see that there isn't, it's not too helpful. It's in a sort of unknown chunk. IDA hasn't helped us really too much. We could have a look at why that is, but actually probably better if we just have a little look and see what's going on. So I like to highlight calls. Ooh. No, let's leave it there. I like to highlight calls by just clicking on call, and then you get a nice little highlight that shows you, dependent on the theme that you're using, if you're using the default, you get this. Cool. We see this thing with settings.ini, probably looking for some form of settings. I don't think it writes to it. I can't see anything. Yeah, I don't see anything. So it's likely that it probably tries to write to it at some point. But if it doesn't, this is not really what we want to look at, because we're more bothered about the generation. So I can see not an offset there, but there's not really. It's to do with possibly a directory is what it's saying there. Yeah, so being used in the path, as we can see here. But actually, we sort of, the only really interesting thing is this and this. So we can see an offset and then the dialog box param WNL with a lot of GUI elements in a lot of different languages. They'll have like a function that's called, so I know, like, say Delphi has like T-form, and sometimes when you look into IDA, there's quite a lot of different GUI elements that you don't think are called, but are actually called, and then you have to delve into them. You could see this function. It's a function by the IDA labeling it func. That could be interesting in itself. Let's just quickly, just for completion, I don't think there's any other strange ones yet. No. So when I mean strange ones, I'm looking at this. So like the API calls here, this is being initialized. We've got a bunch of stuff to do with paths. Really, the two entries that we're interested in are probably here. Have we got? Yeah, we have. Can we? Okay, we can't do that in free. I keep forgetting. So let's initially go into this and see where it goes. We can see something to do with languages, something to do with settings, not too many calls, and I can't see anything really of interest apart from that. So something to look at the default languages, but not too out there. So actually the main body of this is going to be in the dialog func, which is cool. Let's go into that and see what we've got. So initially, straight away, looking at this, I think the thread is going to be the most interesting. So if I just highlight the calls again, as I did before, we can see load API calls. Load image W is probably to do with like the form icon. So like when we load this here, this, that is a complete guess, but that's largely what it usually is. Set Windows text. We've got a call here which might be of interest. Set dialog item text, which is probably what we're going to want to look at because that's setting a form element, which is the calculating, right? And then there seems to be two calls to that, which there's a number of, that could be strings, something to do with strings. Okay, let's just go into, right, okay, that's not an interesting subroutine. So I'm just gonna, what I do is, usually for stuff like this, I haven't initially looked at this, I haven't spent enough time to look at what that could possibly be in relation to. I mean, you could infer this is probably string related in some ways, but I don't want to call that, and you know, it's kind of a, to be fair, it's very short. But that straight off the bat leaves us with really only one path. Yeah, there's only the thread, which is probably, yeah. So into the threads, we've got 4 calls, no, 5 or 6, but we've got the exit thread, so that's interesting to know. We've got no interest again, which we don't need to dive into. And then let's go into this one initially. So this is cool. Okay, so we've got the strings. So this is already looking good because this looks like we've got an allocation of memory. Then we've already got get a device ID from physical drive by the looks of it. String concatenation. Then serial number. Yeah, this is looking good. PPNP, device ID, signature. Windows BIOS serial process name, and yeah, so this is probably print or some variant of print. Okay, so this is likely what I'm going to do is semicolon to just put a comment in here, likely ID gen, and let's just look at the others briefly because that would put some interest for me. So what's this? This is a print by the looks, but what does this do? Not an awful lot. Does be stuff with doing strings, cool, no interest, 0. I mean, you could just, yeah, there's no other, this is probably string related, but out of my just process, I'm going to do that. So we got a print out, so let's just do that. Ooh, is that correct? I've just lost my mind. Yes, this is fine. Everything is calm. Yes, okay, cool. Print out. Yeah, so this is making a lot more sense. ID gen, something to do with a string, print out, and then set that as the dialog item, assuming return is EAX, right? And then we've got EAX there, EDI coming from here, string in there. Yeah, that makes sense. So we've got the string set, which is already telling us that that's going in to EDI, and then we're moving that back in. So I don't really get what, doesn't really matter. That's not what we're looking for. We're looking at the ID gen, but that, I don't know, that's peculiar to me, but I'm not, that's a heap free. That's so fine. Okay, cool. So really, we've just got just that one bit. This is the ID gen, which makes life much easier. It's nice and clean, see? This is why I made the video, because it's nice and clean for me to do. Cool. At this point, I think what I'm going to do is I'm actually going to probably get the debugger up to just see, because at this point, this is kind of an annoying bit where you sort of have to, you can see things being pushed and called, and you've got some strange stuff. What is this? This is some strangeness that we could dive into, but actually, we've got an overall picture of what we're going to do. And it could be execute command actually. Is it used again? We see print out there. Not fully convinced anymore, but it's easier for us to just give it a little dynamic look rather than trying to completely work it out, which is a completely valid process, but this is how I work. I think this is 32. Let's hope. Okay. Okay, can I work from this? Yes, probably. So, let me try and remember, because I'm being super dumb right now. Right, yes, that was the func. In we go. Then we're following into a thread. Yes, yep. Follow into thread. It'd be interesting to see if it goes in, or if it gets funny about the debugger. And then that'll be, is that the gen? I think that's the gen. Let's breakpoint, let's enter in. Yes, that is. Okay, let's see. Let's press the play. It does. That's lovely. That's what we wanted to happen. Let's enter in. We get an allocated heap, which is lovely. The return, of course, is EAX. Let's put that to there, and then let's have a nice little look. So step by step, no needs to be. Just going to double check what a level M sensor. We don't know what that is, but we have had a push. Yeah, we have had a push. Just to confirm. Yeah. So this could be. Let's just see. Yeah, because that's moving. It might just be bringing a string in. No. That in itself, I can see straight away from the errors. SXS key not found, that's something to do with registry. So that is something we are interested in possibly. So we've got a fair bit of calls here. And this is where I'm going to speedily, we can see that's dynamic, not interesting to us at all for now. So we got W key select from, W key out. So we're going to have to enter into this, I think. Yeah, dynamic. I think best bets is to dynamic. Yeah, let's do it. Okay. Let's restart and let's just enter back in. Step in. Let's get that heap allocation. And then let's enter into that and see what happens. So this is where you can get easily lost, but that is fine. So we are entering into that. We're on 22, which is in twice, so that could be interesting for us. Let's see what happens. Oh, actually, I'm sort of thinking that wasn't the one with anything interesting, if I remember correctly. So I'm going to skip it momentarily and see what happens if I get the status key not found. No. What was that return? Nothing of interest right now. And then that's where the key happens. We can see that error. So what I'm going to do is I'm going to restart again because I'm really aggravating. Nice. We're going to go into it. And with co-initialize, see that. We can see a print, which is co-create instance. This is where we're looking into accessing WMIC from what I can see, simply from that root sim string, which is fine, because actually we should label that to not make it no interests. For now, we are interested in this one. because it gets printed. It's querying clearly from WMIC. The reason for that is we can see, yeah, colon security, and then in the next call we have, yeah, this. So we're creating some instances to query in. Select from. Let's see how that goes, because we see a print there already. So let's give it a go. String len 8. Ooh, what on earth is that bad boy? Not a clue. We're getting a print for that. Okay. Push. Some absolute craziness that I think is based on looking at that. Yeah, we don't need to enter into that. I'm going to just skip over that craziness. And I think that was querying, but in such a weird way. That is bizarre. Is it because we have got... let's carry on and see what happened. That was bizarre. Okay, status key not found. This is no interest to us, the 22. We're going to go into here. We're getting more instances of stuff that is querying. We've got an WMI object, okay. The one concern is I didn't see any strings. I'm just seeing a lot of calls, which is fine, but I might have missed something here. Let's keep going. And let's see what that was. Maybe from this. So we're getting serial number. I'm assuming this is right now going to be related to WMIC and then iterating or doing something through it. I'm seeing a variant. I'm seeing serial number being used. I'm not seeing any problems with the return, no errors. So I'm assuming that was correctly inputted. So PNP device ID. That is also, what I'm going to do is I might Google these and then go from there, because these are two different. We're seeing cat as well with that. So what I'm going to do is I'm actually going to Google on Ulster cat W to see yeah, where that's located. Let's just go there. Okay, so we can see the serial number, I'm assuming, and then the PNP device ID from that. That's fine. 3F, is that correct? Let's have a look. $7D. So is that just that or that? My. Harder than I thought it would be. Signature. This is going to concatenate. Let's see. It's printed there, 20B 52A, whatever. It's going to concatenate, yeah. Here, what is that string? Oh, that's string lenning just that, right? Was it ESI? Okay, yeah, that would be, what is that? 8, correct. Variant clear. Then we're going back I'm now getting relatively confused. I'm in the deep weeds of it. 1173. We're not bothered by 1173. Print serial number. Yeah, so it's okay, cool. It's clearing. We're still doing the same. You can actually see throughout this, it's becoming a little bit more clearer. We can see the heap alloc at the start, and then it's got like a repeated process, right? We can see the concatenation. We can see this repeated. How many times is this used? I'm pressing X 3 times, which is confusing, but it's fine. We've got PMP device ID, serial number, signature, which we can look at right now actually. Let's have a little Google on that just to see. Okay, so that's based on the disk drive signature. So I'm guessing because we've talked about the physical hard drive, this is I am inferring because I'm deeply looked into the weeds of WMIC and what it's querying, but I'm assuming when looking at signature and some of the stuff, we had that initial string, which was disk drive. So let's go back and let's have a look at the rest. So so we got the Win32 bus. What happened at the start? Yeah, so we had the physical disk drive there, where we queried. I'm assuming got a handle on it, and then we're querying for the serial number. It's PMP device ID, which I assume will be related to the hard. You know what? I'm gonna kick myself if I don't check while on. Let's have a look. Yeah, this looks relatively related to the disk drive. Although saying that, okay, it's related to the device. Okay, either way, that could be related to the disk drive. We've got the signature, and then we've got a printout, lovely, of, I'm assuming, the signature. And then the variant clear is fine, that's repeated. Then we've got the Win32 BIOS, and then we'll signature it or get querying that, then going on the Win32. And the reason you can, if you've looked at WMIC before, you know the Win32 underscore Win underscore underscore underscore. Jeez, Win32 underscore disk drive. Cool. So we're querying a load of this. We can see the processor name, and we're concatenating throughout. I don't think this is going to be too difficult. Then we're getting a heap alloc here. No, that's not really anything of note. This seems messy, but actually this is just me spitballing with reverse engineering, and it's just a natural process. I feel like a lot of people don't do this sort of stuff and want to be really rigid, but I think it's really beneficial for people to see what it looks like. This is clearly going to be, yeah, we can see, this is so much better. Sometimes threat actors use sort of just straight up assembly to hash, and it kind of, you have to rely on sometimes hash constants or constants, I shouldn't say hash constants, but constants that are used in a hashing process or an encryption process to identify it. That's why there's like IDA scripts and stuff like that they just identify it by its constants or just guess that it is by its length and constant size. But I mean, with this is just like child's play. This is beautiful because they're using the Windows API, which gives us a lot of help. What we can do is we can Google what that is. I'm assuming we're concatenating everything and then just putting it into a hash. So let's go and Google crypt create hash with that constant, and let's see what happens. Crypt create hash. Looks to be MD5 from a glancing look, but to be complete, let's do this. Yes, MD5. Cool. Let's go back. Is there anything else that we need from this? Let's have it. So we've got a printout there. this looks pretty simple. What I'm going to do is I'm going to just cook this up in Python and then generate it and then see what we get, see if they compare the same. Cool, so nothing really too major to explain here. We've got the WMI imported hashlib for the MV5. We are doing essentially the same thing, but just querying much quicker. So we're selecting the serial number, PMP device ID, and signature from the Win32 underscore disk drive. For those, we're using the actual this one, right? You don't want to be using other disk drives. I'm assuming it uses primary, so you're going to want to use 0. So we're joining these all together, which is what it wanted. There was some of these had the hex signature, had one of those where it was printing it out. So if I just go back to, where are we? Yeah, to signature, we had a print. Yeah, you can see here where we're printing out the hex values. So that's what I've done in representation in Python. Similar things here with the serial number in Win32 BIOS, Win32 processor. Then what we're doing is we're hashing it. I did have a sneaky test and of course needed this for some reason, so that's what I've gone for. I think if I remember, I was looking at this, there was some weird, the way it was doing it, this is the encoding that it used in the generator, so I had to use it. This is what it's going to print out a nice little message from me, and then the hardware value. Hopefully they're the exact same. I tested it literally a moment ago, so I'm going to get quite upset if it doesn't. So let's give it a go. Cool, so we've got 9CA. Okay, cool. Have we got that? Let's just get it generating again. 9CA, yeah, there we go. So basically, Citadel used a load of WMIC queries to identify the person's computer. Of course, it was the 2010s, no judgment, but really interesting to go through that and identify it. I quite enjoy doing these sort of videos where we get to see sort of the older side and sort of reverse engineer them. So yeah, if you're interested in more of these videos, please comment down below and I'll give it a go.